Okay, so today's lesson is 3.1 notes, prime factorization and composite numbers, and making the factor tree. So prime number is a whole number greater than 1 that has exactly two positive factors, 1 and itself. An example of a prime number is 3. 3 is a prime number because it has the factors of 1 and 3. When we're talking about factors, we're talking about numbers. Two numbers, when you multiply, you get that number. So example 3, when you multiply 1 times 3, you'll get 3. Composite numbers is a whole number that has more than two positive factors. An example is a 6 is a composite number because it has 1, 2, 3, and 6 as its factor. 1 times 6 is 6, and 2 times 3 is 6. Those are your factors. So if you need to slow it down, please press pause, and then when you're ready, you can go ahead and press play. So this is what you're going to see in your directions. You're going to see identify prime and composite numbers. So here's your steps. List all the factors of the number and tell whether it's prime or composite. So example 1, 23. So first you have to list all the factors. So you know 1 and 23. Now some of you guys learned this as a rainbow, so you make a rainbow. Okay, then you start with 2. Does 2 go into 23? No. 3? No. 4? No. 5? No. And you go all the way until you get to 23. If it's 1 and 23, or 1 and it's the number itself, this means that 23 is prime. Let's look at number 2, 18. So listing the factors of 18, you have 1 and 18. Okay, 2. Does 2 go into 18? Well, if 8 is an even number, you know 2 will go into it. So 2 and 9. How about 3? Does 3 go into 18? Yes. Does 3 times 6 is equal to 18? How about 4? 4 times what is equal to 18? There's nothing. How about 5? Nope. And then you're back to 6 again. So you have all the factors of 18. So this means that because it's more than the 1 and the 18, this means that 18 is composite. So try 3 and 4 on your own, and when you're ready, push play again. So let's look at 3. All the factors of 52 is 1 and 52. Well, 52 is an even number, so you know 2 will go into 52, which is 26. How about 3? Does 3 go into 52? Nope. How about 4? Yes. 4 and 13. Okay. 5? No. 6? No. 7? No. 8? No. 9? You go all the way until you get to 13. And that is all your factors. And this is composite because it has more than 1 and itself. Number 4, it's 1 and 5, and that's it. So this means it's prime because it has only 1 and the number itself. So that's prime and composite numbers. The next step is using a factor tree to find the prime factorization or step diagram. So you may have an option. I'm going to show you both the tree diagram and the step diagram and how to do it, and you can choose which one you're comfortable with. So for the step diagram, or for the tree diagram, you're going to think of two factors. When you multiply, you will get that number. Step 2, continue to break down the number until all factors are prime numbers. Step 3, circle all prime numbers in the factor tree. Step 4, list the prime numbers least to greatest. And step 5, same prime number turns into powers. If this is going too fast for you, go ahead and press pause, and when you're ready, go ahead and press play again. For step diagram, these are your steps. Divide the number into the smallest prime number that it will go into. Continue to divide into the smallest prime number and divide until you reach 1 as the answer or the quotient. So let's do some examples. The number is 36. So for the tree diagram, you put 36 at the top. Think of two numbers when you multiply that you'll get 36. Well, I know 4 times 9 is 36. Now you could have done 2 times 18 or 6 times 6. Any two numbers when you multiply you get 36. Now you got to look at 4. Is that prime or composite? Well, 4 is composite, so you got to continue breaking 4 down. Two numbers when you multiply that you get 4, which would be 2 times 2. And since 2's are prime, you circle it. Let's look at 9. Two numbers when you multiply you get 9 would be 3 times 3. Okay, now you got to list it least to greatest, be 2 times 2 times 3 times 3. Now how many 2's do you have? You have 2, so it'll be 2 to the second times, how many 3's do you have? 3 to the second. So that's how you do tree diagram. Your step diagram, we've done something like a step diagram before. So what you do is 36 and you're going to divide. You always think of the smallest prime number. The smallest prime number is 2. So does 2 go into 36 at all? Yes, which is 18. You still work with 2. You don't go on to the next number. Can 2 go into 18? Yes, which is, then you divide, it would be 9. Okay, does 2 go into 9? No. Next smallest prime number is 3. Does 3 go into 9? Yes. So 3 goes into 9 3 times. Okay, smallest prime number would be 3. 3 goes into 3 once. Once you get to this 1, you stop. In the step diagram, it lists least to greatest for you. So how many 2's are there? There's 2 to the second times 3 to the second. Okay, let's try one more. 128. So try to do it on your own, and when you're ready, you can go ahead and push play. So tree and step. So under tree, you have 128. Two numbers when you multiply, you get 128. Well, I know this is an even number, so I'm going to try 2, and this would be 64. So 2 is prime. 64, two numbers would be 8 and 8. Break down the 8 would be 4 times 2. 2 is prime. Break down the 4 is 2 times 2. Break down this 8 again. So 8 times 8 is 8. 4 times 2 is 8. 2 is prime. And 4 times 4 is, or 4 times, 2 times 2 is 4. Now you count how many 2's you have, because that's the only number. You don't have to write least to greatest. You got 1, 2, 3, 4, 5, 6, 7. So the answer is 2 to the 7th power. Under step, you take 128, divided by smallest prime number is 2, would be 64. This is even number, so you know 2 will go into it, which is 32. This is still an even number, so you can divide by 2, would be 16. 16 is an even number, so you can divide by 2, which is 8. Divide 8 by 2 would be 4. 4 goes into it twice, and 2 goes into it 2 once. And you just have to count how many 2's, which is 2 to the 7th power.